So today's topic is network functions. What is the definition of network functions? The basic difference between two-port network and network function is in two-port networks, we find the parameters either by opening or shorting the input or output port. Whereas network functions, we never open, we never short input or output port. So short circuit, open circuit business will not be there in network functions. But whereas two-port network, every parameter is valid under the condition of either open or short input or output port. That is the basic difference between two-port network parameters and network functions. So V1 by I1 is called as it is voltage and current both at the same point. That is a driving point. It is input port, input impedance function. Whereas I1 by V1 is also a driving point, input admittance function. Current by voltage na admittance function. Together, driving point, input immittance function. So another word is immittance. Immittance means it can be impedance or admittance. V2 by I2 driving point output impedance function. I2 by V2 driving point output admittance function. Together is a driving point output immittance function. So driving point input immittance, a driving point output immittance. Together is a driving point immittance function. Driving point immittance function. If it is voltage in other side, current in one side. V2 by I1 transfer impedance function. If it is V1 by I2 also transfer impedance function. If it is I1 by V2 transfer admittance function. If it is I2 by V1 transfer admittance function. All of them named as a transfer immittance function. If it is V2 by V1 is indicated with G12 called as voltage gain. I2 by I1 is alpha 12 named as current gain. So all above are called as a network functions. So all these possible combinations I have given, different names also given, all of them together as a bunch named as a network functions. Network function is a common word. So any network function, a standard form, n of s equal to p of s by q of s. So it is having like a ratio of polynomials. P of s is one polynomial, P of s is another polynomial. By solving P of s, we get the zeros. By solving Q of s, we get the poles. So any network function n of s is generally represented as ratio of polynomials. Now in two-port networks, parameters are defined with open or short input or output port. But in network function, we don't open or we don't short. This is what I explained already. That is the basic difference between network functions and two-port network. So this is the basic definition. Now, what are the necessary conditions? Necessary conditions for driving point function and transfer functions. So they take up different possible networks. They find out the driving point functions. They find out the transfer functions. What are the commonality? What are the behavior of the poles and zeros and etc. Those things are summarized below. So these properties are very important. So necessary conditions for driving point function and transfer functions. First one, all the coefficients of polynomial P of S and Q of S of N of S equal to P of S by Q of S must be real and positive. Coefficients of polynomial. So P of S is a some polynomial, Q of S is also a polynomial. Those polynomials will have a coefficients. Those coefficients are real and positive. Whereas in the transfer function, P of S coefficients may be negative. This numerator, P of S coefficients can be negative. So coefficient P of S, Q of S coefficients must be real. Q of S coefficients are positive, but P of S may be negative. So that is the difference. P of S coefficients can be negative, whereas Q of S both the sides are same. So I hope this point is clear. Now poles and zeros must be conjugate if imaginary or complex. Poles and zeros must be conjugate. Conjugate means what? If there is a pole at 3 plus J4, there is another pole at 3 minus J4. If there is a pole at J3, there must be a pole at minus J3. So poles and zeros must be conjugate if imaginary or complex. Here also poles and zeros must be conjugate if imaginary or complex. So this is same. Real part of poles and zeros must be negative or zero. If real part is zero, it must be simple. So real part, real value. So poles and zeros will have a complex now. The real value behavior, real value must be negative, if not zero. If it is zero, it must be simple. Hence, more than one pole or zero cannot be located at the same point. Real part of poles must be negative or zero. If real part is zero, it must be simple, including origin. So the same rule is applicable to poles, but not zeros. The poles of P of S and Q of S may not have missing terms between those of highest and lowest degree unless all even or all odd terms are missing. So the poles of P of S and Q of S, polynomials of P of S and Q of S may not have any missing terms. It's a polynomials cannot have a missing terms between those of highest and lowest degree. It means what? If started with s power 4, s power 3 should be there, s power 2 should be there, s power 1, s power 0. So all should be there. Otherwise, all the all even, all odd terms can be missed. Then P of S may not have missing terms, but some of the coefficients may be negative. P of S, numerator, P means numerator, may have a missing terms. So some relaxation in P of S. Some of the coefficients may be negative. This point, say. So here it is polynomial. Polynomials. Now the degree of P of S and Q of S may differ by either 1 or 0. Degree means maximum power of S. So degree of P of S and Q of S may differ by either 1 or 0. Degree of P of S may be as small as 0 independent of degree of P of S. The terms of lowest degree, lower side, in P of S and Q of S may differ in degree by 1 at most. So maximum difference at lower side is 1. If the G12 V2 by V1 or I2 by I1 rule is maximum degree of P of S is equal to degree of Q of S. If it is Z12 or Y12, maximum degree of P of S is equal to degree of Q of S plus 1. So these are the standard conditions, and they are necessary conditions. Everyone should remember. Don't read before, earlier, just to read before the exam so that you can remember. So based on these properties, I have taken some examples. So this is one example: 4s to the power of 4 plus s square minus 3s plus 1 by s power 3 plus 2s square plus 2s plus 40. So is it correct or wrong? We have to decide. So in the numerator, one coefficient is missing and one is negative. One coefficient is missing, s power 4. So 3 is missing, that is one fault. And here one is negative. One coefficient is negative. Then in denominator, s power 3 factorize s plus 4 into s square minus 2s plus 10 is having poles in RHS. So this one, if you solve, it is having poles in RHS. S equal to minus 4. This also solve. It is having poles in, sorry, S equal to minus 4 is left side, but this will have a poles in right side. So it should not have poles in right side. So this is not the valid driving point function. Whereas second one, 15 of s power 3 plus 2s square plus 3s plus 2 by s power 4 plus 6s power 3 plus 8s square. So denominator, if you see double pole at origin, if you take s square common, then s square term will have a 2 poles at origin. Double pole at origin not permitted. Then another deviation, the terms of lowest degree, lower side numerator is 0, denominator is 2, the difference is 2. So what is the difference? It should be 1 only maximum, but here 2. So this is also not the valid driving point function. There is another example, s square plus s plus 2 by 2s square plus s plus 1 satisfies all the necessary conditions, but we can't guarantee that it is a driving point function. So necessary and sufficient condition will be studied in network synthesis. So here, what is the meaning of necessary condition? All conditions are satisfied. All conditions are satisfied, but there is no guarantee that it is a valid Z of S. So it is not valid driving point function, even though all rules are satisfied. So that means any given a really existing network, if you find a transfer function, the transfer function will satisfy all the conditions just now we listed out. Now you take a random function which will satisfy all the rules, but if you go back to realize the network, you may not get the network. That is the meaning of necessary conditions. So these are some of the examples which are deviating the rules. This is deviating the rule, this is deviating the rule. It's satisfying all the rules, but it is not a valid Z of S. That is the meaning of necessary condition. So in this basic definition and these necessary conditions important. Sometimes in the exam, these examples, the way how I have given, like that they ask. Now little bit bigger problems, essay type problems. This is one network. Find G12. What is G12? V2 by V1. So V2 is here, V1 is here. Don't think this is like a port. Here V2 is the voltage. Don't take extra I2 here. Don't think this is I1. So in this network, here V2 marked, here V1 marked. So V2 by V1 only we have to find. And here IA, 2IA, na? This is depending on this current. So this is what given, 2V1. So V1 is here. So this network you have to find V2 by V1. So how to solve this problem? So here IA already there, here 2IA is there. What is the current in this will be 3IA. 3IA. So 3IA will flow here. 3IA. So don't take here I2. Then it will become I2 plus 3IA, which is wrong. Okay. So what are the equations we can write? V2 is equal to 3IA into 1. This is one equation. The second equation is we can go for this outer loop. That is V1 is equal to EA into 1, this IA into 1 plus 3IA into 1, 3IA into 1 plus 2V1 plus 3IA into 1. This is second equation. Can simplify further. 3 plus 1, 4. 4 plus 3, 7 IA. So when this is coming this side, minus V1. Okay. So from this, what is IA value? Minus V1 by 7. So therefore here V2 is equal to minus 3. IA is what? Plus 3 IA. IA is minus V1 by 7. So V2 by V1 equal to minus 3 by 7. So minus 0.428. This is. Similarly, second problem, another problem. Is asked in gate 95. But old model at 95, they used to ask essay type questions also. But in this case, find alpha 1 to I2 by I1. So I2 is given here, I1 is given here. Okay. So you can, how you can solve this one is here I2 given. So this current is I2 and this current is I1 by 2. This is I1 by 2 plus I. So you're added with IA. So this will be IA plus I1 by 2 plus I2. This current added with I1. So what is this current now? IA, I1 plus I1 by 2. So 3I1 by 2 plus I2. Unwanted is IA. IA we have to eliminate, take the ratio of I2 by I1. So probably one loop equation is this. So what is that loop equation is? Minus IA plus 3I1 by 2 plus I2 minus 2IA minus IA into 1 equal to 0. So this we have to simplify. Everywhere minus, you can make it plus. 2IA plus IA 3, 3 plus 1, 4. So 4IA plus 3I1 by 2 plus I2 equal to 0. Yeah. This second equation is we can write this loop. This loop should not go through current source. So that is IA minus 2 into I1 by 2 plus I2 then minus I2 into 1 equal to. So here IA minus I1 minus 2I2 minus I2. So minus 3I2 equal to 0. Now here I1, I2, IA. Here I1, I2, IA. So this IA substitute here. What is IA from this? I1 plus 3I2. So this we have to substitute here. 4 into I1 plus 3I2 plus 3I1 by 2 plus I2 equal to 0. Now we have only I1, I2 na. Now take the ratio. Take the ratio alpha 1 to alpha 1 is equal to I2 by I1 minus 0.42. We'll get answer. So this is the answer. So like this, any question they can ask. I2 by I1, V2 by V1, V1 by I1, V2 by I2, and so on. So any one of the network function they can ask. So this is another problem. Y1 to I2 by V1. I2 is here. I2 is here. I2 by V1. So I2 by V1 already came to S plus 1 by S plus 2 and S plus 3, S plus 4. Determined value and sign of K. So this K value we have to find. How to solve this? First, simplify this parallel combination. This parallel. These two are parallel. Na? So here 1 by SC. 1 by SC. So what is the C value? 2 by 3. It is equal to 3 by 2S. Is parallel with 3 by 2. So that means 3 by 2 into 3 by 2S by 3 by 2 plus 3 by 2S, which is equal to 9 by 2 by 2S whole divided by LCM 2S. Then you get 3S plus 3. So this 2S will go. Then 9 by 2 by 3 common, S plus 1. So it is nothing but 3 by 2 into S plus 1. Like that, this also we have to simplify. What is that one? So there 1 by 2S. 1 by 2S is parallel with 1 by 6 by 1 by 2S plus 1 by 6. It is equal to 1 by 2LS by 6S is LCM, then 3 plus S. So it is equal to 1 by 12S into 6S by S plus 3. So this is 2. So 1 by 2 into S plus 3. Now if you see here, V2 is voltage across this equivalent, and this is added with 1. This equivalent is added with 1. Now using voltage division theorem, using voltage, V2 is across this total equivalent. Now here it is 1 is added. There is also another simplification. 3 by 2 into S plus 1 plus 1, which is equal to 3 plus 2S plus 2. 2S plus 2 by 2 into S plus 1 is equal to 2S plus 5 by 2 into S plus 1. Or you can also write S plus 5 by 2 by 2 to cancel S plus 1. Now voltage division between, so V2 is equal to V1 into 1 by 2 into S plus 3 whole divided by 1 by 2 into s plus 3 plus s plus 5 by 2 by s plus 1. But what is the value of V2? This I2 is flowing here now. What is the current in this? This is I2. So started positive, go to negative. What you get V2? Minus I2 by 6. So this value minus I2 by 6. Minus I2 by 6. So what we want? V1 by I2. The question is I2 by V1. Question is I2 by V1. So simplify I2 by V1, you find out. So just for saving the time, so simplify, you will get I2 by V1 answer will be minus 3 into S plus 1 by S plus 2 into S plus 4 will come. So if you compare, what is the K answer? Minus. So just this simplification, you do it, you will get the answer. So this is how you can find out. So this step is only important. V2 is this is V2 means what is the voltage here? V2 only, na? So V2 is the voltage across this equivalent. And also find out this equivalent, this total equivalent. This total equivalent, this equivalent connected in series. Now use voltage division. V2 is equal to V1 into this equivalent divided by this equivalent plus this equivalent. That is the step done here. So simplify that. Yeah. This is another problem. A network is given, Z of S. Z of S, some network is given. Its poles and zeros location also given. Poles and zeros location also given. Now Z of S looks like K into S minus Z1 by S minus P1 into S minus P2. Determine Z1, P1, P2 in terms of RLC. If Z of 0 equal to 1, and also find RLC values. Also find RLC value. So it is having a 0 at minus 3, pole at minus 1.5, and here minus, here actually J. So here is J. J root 1 by 2. Root 1 by 2. Root is not for 2. Root is not there for 2. So minus J root 111 by 2. Root is not there for 2. So how the Z of S will be? We have some constant K. It is having 0 at minus 3. That means S plus 3 by, we have a pole. So S plus 1.5 plus J root 11 by 2 is one pole. Another one S plus 1.5 minus J 11 by 2. So this we have to simplify. Is equal to K S plus 3 by by So here this is one term x plus jy. This is x minus jy. X plus jy. X minus jy is what? X square plus y square. That means s plus 1.5 square plus 5 square. 1 by 4. So this is k s plus 3 by s square plus 1.5 square is 2.25. Then 3s plus 111 by 4. 27.75. So it is further k into s plus 3 by s square plus 3s plus. So this will be 27 plus 3, you'll get 30. 30. Okay. What is given? Z of 0 is 1 given. Z of 0 is 1. It is already given. Z of 0 is 1. Z of 0, 1 means Z of 0 equal to 1 given. S equal to 0. So this is 0, this is 0, this is 0. 3 by 30. 3 by 30 is 1 by 10. 1 by 10. So 0.1 k. So what is k value is 10. K value is 10. K value is 10. We got it. So this k also we determined. Now this Z of S we have to find. RL series, capacitor parallel. So Z of S equal to RL series na R plus SL is parallel with the capacitor. 1 by SC by R plus SL plus 1 by S. So here S L is common. S plus R by L by S CR S square LC plus 1. SC cancel. S plus R by L by LC common. S square plus SR by L plus 1 by LC. So LL cancel. Z of S equal to 1 by C S plus R by L by S square plus R by L plus 1 by L. So this is further. We have to solve this S1 2. So S1 comma 2 will be minus R by L. SR minus root of B square. R by L square minus 4 by LC by 2A. So 1. So minus R by 2L star minus root of r by 2l square minus 1 by l. So this is plus with plus p1 minus p2. So we can write z of s as k into what is given as minus z1 by s minus p1 s minus p2. This is k. So we have a s plus r by l. S plus r by l by s minus r by 2l plus root of r by 2l square minus 1 by lt s minus r by 2l minus root of r by 2l square minus 1 by l. Now this we have to compare. Here we got 1 by c, not k, here 1 by c. What is the k answer we got? K we got 10. That means 1 by c equal to 10. C equal to 0.1 farad. So this one answer we got. Next, here s plus 3 we got it now. You see in the beginning s plus 3. So that we are comparing. That means r by l equal to 3. R by l equal to 3. So if you know one value, other we can find. What is other one? R by 2l, R by 2l minus r by 2l plus root of r by 2l square minus 1 by lc is equal to what? Minus 1.5 plus root triple 1 by 2. So this again same. This is same. So only this one, if you compare r by 2l square minus 1 by lc triple 1 by 2. So in this c value is known. C value is known. Two unknowns, two equations. Here c is known na. So r value, l value. Here r value, l value. So r equal to from this r equal to 3l. So here r equal to 3l. 3l by 2l square minus 1 by l. L into c is 0.1 equal to triple 1 by 2. So what is the unknown in this case? Only L. Here LL cancel. So this L solve. This L you solve. We'll get answer 0.36. 0.36 Henry. So this L value substitute here is solve for R. So like this we can find out RLC values. and k value and so on. With z of 0 equal to 1, we determine the value of k. And this network we find poles and zeros. Numericals also given poles and zero. By comparing RLC values, we find out. That is the basic idea. Now, this is another problem. Tests on some test is conducted on a certain network showed that the current output was I of t equal to so and so when U of t volt was applied at the input. What voltage must be applied to give an output current of I of t if the network remain in the same form? So what is the I of t given? What is the I of t given is minus 2 e power minus t plus 4 e power minus 3t. With what input? When input is U of t applied. So there is a sum network. To this network, when U of t is applied, it is giving I of t. So this is the network. So when U of t applied, this system is giving I of t as shown. Now, what voltage must be applied to give the output current of? To get this answer, what is the input we have to apply? The network remain same. That is the idea. So first we have to find transfer function. So what is the transfer function definition? It is the ratio of Laplace transform to output by input. Ratio of Laplace transform of response by excitation. What is the Laplace of output? Minus 2 by s plus 1 plus 4 by s plus 3. This is the response output. By Laplace of input is 1 by s. So this we have to simplify. So what is this simplification? S plus 1 into s plus 3. So minus 2 into s plus 3 plus 4 into s plus 1 all divided by 1 by s. So this is equal to minus 2s minus 6 plus 4s plus 4 by s plus 1 into s plus 3 into s by 1. So minus 2s plus 4s is 2s. Here minus 6 plus 4 is minus 2 by s plus 1 s plus 3. Here I think we have done all. Yeah, minus 2 only. Plus 4. Yeah. Now to get the current of 2 into e power minus t, if the network remains n, what must be applied? What is output is I of s. What is input is Vi of s is equal to what we got, 2 s minus 1 by s plus 1 into s plus 3. What is Vi of s in this case? I of s into s plus 1, s plus 3 by 2 into s minus 1. So we are solving for Vi of s. But what is I of s given in the problem? 2 into e power minus t. So 2 into 1 by s plus 1, s plus 1, s plus 3 by 2 into s minus 1. So this will go 2 into 2 also will cancel, s plus 3 by s minus 1 is nothing but s by, or otherwise s minus 1 plus 4 by s minus 1. So 1 plus 4 by s minus 1. So what is input now? Inverse of 1 is delta of t plus 4 e power minus t. This is the input we have to apply. This is answer. So like this we can solve. Okay. So with this I am stopping. So network function is over.